Hello everyone. So this is the question. Count of arrays in which all adjacent elements are such that one of them divide the another. So in this question, we are given two positive integers n and m. Our task is to find the number of arrays of size n such that there are two conditions. Each element is in range 1 to m, both included, and all adjacent elements are such that one of them divide the another. That is, AI divides AI plus 1 or AI plus 1 divides AI as well as AI divides AI minus 1 or AI minus 1 divides AI. For example, if n equal to 5, that is size of array is 5. So here are the 5 elements A0, A1, A2, A3 and A4. So A0 and A1 are neighboring elements. So A0 should be divisible by A1 or A1 should be divisible by A0. Similarly, A1 and A2, A2 and A3 and A3 and A4 are the adjacent elements. So similarly, they all should also divide each other. That is, A1 should divide A2 or A2 should divide A1, A2 should divide A3 or A3 should divide A2 and so on. So let's look at an example. So if input is n equal to 2 and m equal to 4, that means size of array should be 2 and elements can be from 1 to 4. Then our output is 17. That is, there are total 17 possible arrays. So let's look at the arrays. 1 comma 1, because 1 is a factor of 1 and they are also adjacent elements. So because there are only two elements in the array, so obviously they are adjacent, all the elements in the array. 1 comma 2, 1 is a factor of 2. 1 comma 3, 1 is a factor of 3. 2 comma 4, 2 is a factor of 4. 3 comma 1, 3 is a multiple of 1. So it can either be a factor or a multiple. Because if A is a factor of B, then we can also say that B is a multiple of A. So it is similar as saying that 3 is a multiple of A is similar as 1 is a factor of 3. Similarly, 4 is a factor of 4. 4 is a multiple of 2. So here we see that 1 comma 1 A0 divide A1 and in 1 comma 2 A0 divide A1 and in 4 comma 2 A1 divide A0 and so on. So either A0 should divide A1 or A1 should divide A0 for n equal to 2 and m equal to 4. So now look at another example. N equal to 3 and m equal to 4. So that means the array size should be 3 and we can have elements from 1 to 3. So let's assume the first element is 1. If first element is 1, we can go to 1, 2 or 3 for the next element. Why? Because 1 is a factor of 1, so we can have 1 as second element. 2 and 3 are the multiple of 1, so we can also have 2 and 3. So now first element is 1 and let's suppose second element is 1. Again 1. Then the third element can be either 1, 2 or 3 for the similar reason as previous. That is 1 is a factor of 1, 2 is a multiple of 1 and 3 is a multiple of 1. Similarly, if first element is 1 and second element is 2, then the third element can either be 1 or 2 and not 3 because 3 is neither a factor of 2 nor a multiple of 2 and 3 and second and third element are adjacent. Similarly, if first element is 1, second element is 3, then third element can be either 1 or 3 because 1 is a factor of 3 and 3 is a factor of 3, but 2 is neither a factor of 3 nor a multiple of 3. Similarly, we can have similar types for first element is 2, then we can have second element is 1 and 2, and third element can be these. For n equal first element is 3, then we can have second element as 1 and 3, and then the third element can be any of these. So, how we make an array for this? Like 1, 1 and 1. So 1 comma 1 comma 1, this is one array. Then we just have to traverse. Like if we go from 1, 1 and 3, then the element is 1 comma 1 comma 3. So this is also the possible array. If we go from 1 to 3, that is second element is 3, and then again we go to 3, then the element we have is 1 comma 3 comma 3. So this is how it is done. Also, like if first element is 2, second element is 1, then we have three option, and if we go to third option, that is 3, then we have a array as 2 comma 1 comma 3. So this is how we can do it. Okay, so we will solve this question with the help of dynamic programming. So example we will take will be same as before, that is n equal to 3 and m equal to 3. So what we do, we make an array and of size n plus 1 and m plus 1, because here we are using the elements from index 1 to n and 1 to m. So in this array, row number defines the size of array. That is, if we have first row, then it means there is an array of size 1. If there is second row, it means there is an array of size 2, and if it is 3, it means there is an array of size 3, and so on. For column number, it represents the array starting element. That is, if we have first column, then it means that first element of the array is 1. If we have column number as 2, then it means that the first element of the array is 2. If the column number is 3, it means the first element of the array is 3. So, like this is 2 and this is 2. So, this will be, there is an array of size 2 in which first element is 2. And like if we take this 3 and this 2, that is row number 3 and column number 2, like this one. So, it means that there is an array of size 3 and which has starting element as 2. So, what one thing we can notice, that if there is an array of size 1 and the first element is 1, then we can only have one element, that is 1. If we have an array of size, similarly for array of size 1, if the first element is 2, then there can only be one element, that is 2. And if there is an array of size 1 and first element is already defined, it is 3, then we can only have one element, that is 3. So 1 comma 1 1. So similarly, you will see that for an array of size 1 and for any column number, there will be only one possible array. So now let's move on to the second row. Second row means there is an element array of size 2. So the first element is 1 in the array and arrays of size 2. Then the second element can either be 1, 2 or 3, because 1 is a factor of 1 and 2 and 3 are multiple of 1. So this will be 1 plus 1 plus 1 from above we can see. So this will be 3. Why? See, if first element is 1, then we can go to either 1, 2 and 3. So total are 3 numbers. So we have 3. Now if the first element is 2, then for second element we can have how many values? If first element is 2, then for second we have 2 values. So we will fill 2. For if the starting element is 3, then for the second element we can have how many values? 2. Because from 3 we can either go to 1, that is factor of 3, or 3, that is also a factor of 3. So we can have two elements. So we'll also see that if what we do, we just add the factors and the multiples of that element from the previous row. That is, for 3 what we did, what are factors and multiples? 1, 2 and 3. So we just added the elements from the previous row, that is 1, 1, 1. For 2, 1 and 2 are the factors and multiple of 2. So from the previous row we added first column and second column, that is 1 and 1. And similarly for 3. Now for an array of size 3, If the first element is 1, like this, then for the third element, we can have how many values? 1, 2, 3, 4, 5, 6, 7. 7 values. We can also fill from this table, that is a factor of 1 is 1 and multiple of 1 is 2 and 3. So what we did, we add 3 plus 2 plus 2, that is 7. For 2, factor of 2 is 1, comma 2. So we will add 3 and 2, that is 5. Now again for factor of 3 and multiple of 3, we have two elements, that is 1 and 3. So we'll add 3 and 2, that is 5. Now the table is filled. So now what we will do, we will just add the last row. All the elements of last row, that is 7 plus 5, which will be 17, and this is our result. Why? See, if the first element is 1, then for the last element, that is third element, we can have how many values? 7. If the array starts from 2, we can have 5 values, and if the array starts from 3, then we can also have 5 values. So this is total number we get is the all these numbers, that is 7 plus 5 plus 5, that is 17. Now let's look at the code. So this is the main. We just input two values n and m, and we pass these values into the function named as count. This is the function. So as I told you earlier, we declared an array of size n plus 1 and m plus 1 because we use the index from 1 to n and 1 to m for rows and columns. So, as you saw earlier, that we were using factors and multiples. We were counting factors and multiples. So, for that, what we do, we declare two vectors named fa for storing the factors and mu for storing the multiples of the elements. Then, this code, what does this code does? It initializes all the array elements with 0. Now, this is the part where we calculate the factors and multiples of the elements. First thing, every I dot push back I, because every number is a factor of itself. So like if I is 1, then 1 is a factor of 1. If I is 2, then 2 is a factor of 2. So we simply push that I. Now for each equal to 2, what we do, we multiply j and I. So, like if I is 1, then j is 2, then next time j is 3 and 4. So, for k we have values 2, 3, 4, 5, which are the multiples of 1. If I is 2, we have j equal to 2, that is 2 into 2. Next time we have 2 into 3, then 2 into 4, and similarly. So, what does k does? K is simply the multiple. Every time we count, we have the next multiple of that number. So for like 3, first we will have 3 into 2, then 3 into 3, then 3 into 4. So we count all the multiples of that number. MUI dot pushback k. Like if I is 1, then we will k will have all the multiples of I. That is first it will have 1, then 2. First it will have 2, then 3, then 4. So we just push back k. Now you see that for factors we just interchange the value of k and I. Why? Because as I told you earlier also, if A is a factor of B, then we can also say B is a multiple of A. So if K is a multiple of I, then we can also say that I is a factor of K. So we calculated the factors and multiple. Now what we do? So we initialize the first row with 1. As I told you earlier also, because its size is 1, then for all values of I, we can have only one element. Then for this code, what we do, we calculate the number of values which the array can have. And like for dpij, we calculate the factors and then we also add the multiples. So as you can see that we have I minus 1, that is we go to the previous row. Like for this also, as I told earlier, if we have to calculate the this, that is an array of size 2 with the first element as 1, then we calculate the factors and multiples. That is, factor of 1 is 1 and multiple is 2 and 3. So we just go to the previous row, that is row 1, and then we add the values which are given, that is 1 plus 1 plus 1. So we simply added the number of factors and added the number of multiples. And then at last we added all the elements of the last row. As I told you earlier also, the last row will give us the answer, because if we can have first element as any value from 1 to m. So we just calculate that if the first element is 1, then how many values can we have at the last element? If first element is 2, then how many values we can have? And so for the last row, we just have to add and we get the result.